This video is about circles and their equations and their graphs. A circle is defined to be, or can be described as, the set of all points xy, a fixed distance r, from a single point called the center, and usually in our textbooks that center is represented by HK. So let's say this is our H and that's our K. Well, the center would be right there. We'll plot that. And this circle is defined to be the set of all points that are the same distance r from HK. So if I go r units in this direction to h plus r, and r units in this direction to h minus r, those are points on my circle. And if I go r units in this direction, if that was y equals k, that's going to be y equals k plus r. If I go r units in this direction, I go down from the center, that's going to be y equals k minus r. It doesn't really look like a circle. It's supposed to be a circle. A circle is a set of all points that look like that. Every single point on this circle, which is represented by xy, is a distance r from the center, which is given by hk. I might say, okay, well that's easy enough. I know how to draw a circle. You've probably seen circles before this class. But if we want the equation of a circle, that's easy enough to do. We just use the distance formula. Now the distance between 2 points, let's say P, which has coordinates x1 and y1, and a point Q, which has coordinates x2 and y2, well, that distance formula can be derived by creating a right triangle. So let's plot x1, y1, that's P, and x2, y2, that's the point Q. And so the distance that we want, that's the distance from there to there. If I want that distance, the easiest way to come up with that distance is to use this as the hypotenuse of a right triangle. So I'm going to draw a side of the triangle that's parallel to the x-axis, and I'll draw a side of the triangle that's parallel to the y-axis. And we know from the Pythagorean Theorem that this side squared plus this side squared equals the hypotenuse squared. We just have to find the lengths of the sides, and then we can solve for the distance d. Now if this was, let's just say x equals 1 and this was x equals 10, we know the distance between 1 and 10 is 9 because we just take this x value and subtract this x value. That's always going to be the same. If I take this x value and subtract this x value, that'll be that distance right there. And if this was 4 and that was 2, the difference between those would be 2. So this distance is just that y value minus that y value. So we're going to have y2 minus y1 there. So according to the Pythagorean Theorem, this leg squared plus this leg squared equals the hypotenuse squared. So the distance squared is x2 minus x1 squared plus y2 minus y1 squared. And if I want to get the distance by itself, I just take the square root of both sides. So now I've got the distance between those 2 points. Now with this distance formula, I can derive the equation for a circle over here. Because this circle is a set of all points that are the same distance, that distance is r, from a given point. So this could be my P, and this could be my Q, and I can use the distance formula to write an equation involving x, y, h, k, and r. So the distance is equal to r, which is equal to the square root of, we take that second point's coordinates, that was x2, y2, and we subtract the coordinates of the first point. Oops. So let me make this my Q, and this my P. So if this is my Q, I'm going to take my x and y, that's my x2, y2, and I'm going to subtract the x from here and the y from here. So I'm going to have x minus h squared plus y minus k squared equals r. Or, using the Pythagorean theorem over here, this distance is y minus k, this distance is x minus h, and this squared plus this squared has to equal r squared. So we have, by the Pythagorean theorem, r squared equals that without the square root, or I can rearrange it, x minus h squared plus y minus k squared equals r squared. That's the equation of a circle in standard form. And this is a circle with center HK and radius R. Alright, and that's true over here. Now this is true for any point xy in the circle. It would work just as easily, work just as well with this other point xy in the circle. The distance from here to here is also R. So x and y are being treated as variables here. H and k, those are the coordinates of the center, and r is the radius. And it's going to be the same all the time. So with that in mind, let's look at some examples. Let's say you're asked to find the standard form of the equation of a circle with a center at -2, 3 and radius 4. And then maybe after we do that, we also want to graph it. Okay. So the first thing I would do, well, I want to graph it first. I think I'm going to graph it first. So I'm going to plot my center point when x equals -2, y equals 3, and then we want to go 4 units in all directions. So from -2, 3, I want to go to the right 4 units. If I go right 4 units from -2, I'm going to end up at +2. That's 1, 2, 3, 4. Don't count the first point. And then we want to go left 4 units. So we're going to go back to -6. Then we want to go up 4 units. So that's going to leave us at 7. And down 4 units. So down 4 units from 3 is -1. And then we connect those with a smooth curve, and it would be more circular looking if I had graph paper, if it was a better graph, if all these tick marks were even the way that they're supposed to be. But that's the idea. It's not to scale. You can just say that's R and R equals 4. Okay. So this is our circle. Now if I want to write the equation of this circle down, I'm just going to use this placeholder form. It's going to be x minus h squared, plus y minus k squared equals r squared. And we're just going to substitute in h and k and r. H is -2. K is 3. That's our h and that's our k. And r is 4. So that's the equation. It's just not simplified. Subtracting a negative is the same as adding. So that's going to be x plus 2 squared. And then we'll have y minus 3 squared equals 4 squared, which is 16. So it's that easy. Now let's say I wanted the equation of a circle with center 2, 0 and radius 3. It's going to be exactly the same. Write down your standard form. With this placeholder notation, I've got spaces to fill in my h, my k, and my r. H is 2, k is 0, that's h and k, and r is 3. So we substitute in 2, 0, and 3, and then simplify. X minus 2 squared doesn't simplify, don't actually multiply it out, just leave it alone, leave it factored that way. And then y minus 0 is just y, that's squared, and 3 squared is 9. Alright, so with regard to circles, I could give you the center and the radius and ask you to write the equation in standard form. I could also ask you to graph it. So we have two examples like this. Or we could go the other way. I could give you this equation in standard form, and I could ask you for this center. I could ask you for the center and the radius. So be careful with this one. We're doing the same thing, just backwards. So let's say you're given that x plus 1 squared plus y plus 3 squared equals 25. Well, through pattern matching, this is x minus h squared plus y minus k squared equals r squared. There's my h, my k, and my r. You might be asked to find the center and radius of the circle and then graph it. Well, that's easy enough. The center is given by hk. Now, it's very tempting to just write a 1 for h, but notice that that's a minus and that's a plus. So whatever you see here, if you see a plus 1, the h is going to have the opposite sign. H is -1. If you're wondering why that's true, it's because we're subtracting a -1, and that means we're adding 1. So that's a plus 1, so I'm going to change the sign, make it a minus. That's a plus 3, so I'm going to change the sign, make it a minus. So that's my h and that's my k. Now this is not the radius, it's the radius squared. So we know the radius squared is 25. If I want to get the radius by itself, I need to take the square root of both sides, and the radius is a distance. It's always positive, or possibly 0. Then it's just a single point. It's not much of a circle. So you're going to take the positive square root. So r is 5. So that's our radius. Okay, so we've got our center and our radius, and now we want to graph it. So I want to go out to x equals -1, y equals -3. Plot a point, and I want to go 5 units in all 4 directions. I want to go up 5 and down 5. To the right 5 and to the left 5. And then connect those with a smooth curve. It's supposed to be a circle. Try to make it look like a circle. There you go. And that is the center and the radius, and that's the graph. Now if anybody ever asks you for the domain, they ask you to find the domain and range of this relation. Remember, the domain is a set of inputs, or in our graph, it's a set of x values that have y values. So the domain is some subset of the entire real line. So we're going from negative infinity on the right to positive infinity on the left for x. But it's just the x values that have y values. So you want to start the domain as soon as that graph starts. And notice it starts right here. At x equals -7, there's no y value. -6.5, no y value. -6.1, there's nothing. But at -6, bam, there's a y value. So that's in our domain. We start here at -6, and we keep going. We've got a graph, we've got a graph, we've got a graph until we get to 4, and then it stops. So the domain of this is the interval including the endpoints starting at -6 and ending at 4. And the range starts at the bottom and goes to the top. The lowest y value is y equals -8. And then it goes all the way up to y equals 2, and then it doesn't go beyond y equals 2. So it stops there. If y equals -8 to y equals 2. So you go from smallest to largest. That's the range. Okay, so I could give you the circle in standard form and ask you for the center and the radius. I might ask you to graph it. I might ask you for the domain and range, or it could go the other way where I give you the center and radius and I ask you to plug those in and give me the equation in standard form. Now here's another one that's kind of interesting. Sometimes textbook authors and homework platforms, they might ask you to do something like this. They might say, find a circle, or find the equation of the circle of radius 1 that basically started at the origin. So it initially had its center at the origin. And was shifted 4 units to the right and down 2 units. So let's think about this. It's just a circle of radius 1. So it goes from -1 to 1 and 1 to 1. And they said initially it was centered at 0, 0. So we're right here. And now we're going to take this whole thing and we're going to shift it 4 units this way. So I want to go over 1, 2, 3, 4. And then I want to go down 2 units. So this is -1, and that's -2. Or if I go from -1, I go -1, or -2, -3. Okay, now I could shift each of these points individually. I could shift this one 4 units to the right and down 2. And I could shift this one 4 units to the right and down 2. And I could do that for all of them. Or I think it's better if we just think about moving that center and remember that we're talking about all of the points that are 1 unit from the center. So we're taking our center, which was at 0, 0, and we're shifting it 4 units to the right. So our new x value is x equals 4. And then we're shifting it down 2 units. So we went 4 units this way and down 2. This is our new center. So from this center point, if it has a radius of 1, it's the exact same circle, but it's centered here now. We're going to go left 1 and right 1, and up 1 and down 1. What's the equation of that circle? Well, it's got a new HK, doesn't it? The x coordinate of our center, that's h, that's 4, and the y coordinate of our center is 2, so that's k. The radius, that hasn't changed, r is still equal to 1. So our equation is x minus h squared plus y minus k squared equals r squared, and that's 1. So h is 4, k is 2, so that's our h and that's our k, and r was 1, so we're just squaring 1. And there's not much to simplify here, but the 1 squared, of course, simplifies to 1. And so that's the equation in standard form. So whenever you see this equation, you can think of it as the circle of radius 1 that's been moved 4 units this way and down 2 units this way. I made a mistake. Did you guys see what my mistake is? K is not 2, K is negative 2. So that makes that a negative 2, and subtracting a negative means we're adding 2. Oh, that's much better. All right, so shifting 4 units this way, that led to this minus 4 here. And shifting down 2 units in the y direction led to that plus 2 inside. So remember when we talked about transformations, this was shifting left and right, and this was shifting, changing the y's was shifting up and down. That still has not changed. So that's our last example of that. We're going to look at one more example of circles, and then we'll be done. Now sometimes, rather than giving you the equation in standard form and asking you for the center and the radius, they can give you the center and radius and ask for the equation in standard form. Any of these times we can talk about graphing them. We can also talk about taking a circle that's centered at 0, 0 and moving it around the xy plane by moving that center point. Now sometimes our circles look like this instead. You might not even think this is a circle, but it is a circle. That's a circle because it's got the x squared plus y squared in it. But it's not obvious what the center is, so we need to rewrite it in standard form. And we're going to rewrite this in standard form by completing the square. So let's talk about what somebody might ask you. They might say, given this equation, write the equation in standard form. And then if it's a circle, and we'll talk about when it might not be a circle. If it is a circle, you might want to find the center and radius of that circle. And then of course we can always graph it. Okay. So we're going to write this equation in standard form, and the method is by completing the square. And then once we complete the square, we're going to look at what we found and see whether or not it represents a circle. But we'll talk about that when we get there. So let's talk about completing the square. Oops, I wrote two different y's. I don't know why I wrote y twice. That should be an x. There we go. Okay, in order to complete this square, we want to get the x terms together and the y's terms together, and we want to add that constant to the other side. So let's add the 23 to both sides. So that's not there anymore. And on this side, you want to group the x's together. So you've got an x squared and a 4x. Leave a space, and then add the y squared and the minus 6y. And then on the other side, you still have a 23. Now each of these need us to complete the square. Now, whenever you're completing the square, there has to be a coefficient of 1 in front of the squared term. Now there already is on this one, there's an implied 1 there and an implied 1 there, so we can jump right into completing the square. But if there was a 2 there, I'd have to factor it out from both terms. Or if there was a 3 on this one or a 4 on this one, I'd have to factor that 3 or 4 out from the y squared and the 6y. But this time we don't have to because there's just a 1 there, so we can get right into completing the square. In order to figure out what to add here to make this a perfect square, I identify b, that's the number in front of x, it's 4. You want to take half of that and square it. So half of 4 is 2, and 2 squared is 4. That's what you need to add to complete the square. Now we just added 4 to the left-hand side. In order to compensate, we need to make sure we add 4 to the right-hand side as well. We're going to do the same thing over here. Identify b, that's -6, compute half of it, that's -3. Then square that. -3 times -3 is +9. You want to add 9 to complete the square, and add 9 over here. Okay, so now this is a perfect square, and this is a perfect square. It just hasn't been factored. And then this expression on the other side is just a constant that we can simplify. So let's do that. This is x squared plus 4x plus 4. I need two numbers that multiply to give me 4 that add to 4. Plus 2 and plus 2 would work, so that's x plus 2 squared. Here, I need two numbers that multiply to give me 9, product of 9, and add to give me -6. -3 and -3 will work. -3 plus -3 is -6, and -3 squared is 9. On the right-hand side, you've got 4 and 9, that's 13, and 13 and 23 is 36. So this is the point when we say, yes, we've completed the square, we've written the equation in standard form, and notice the right-hand side. If that right-hand side is positive, even if it's not a perfect square, if it's a 17, it's totally fine. If the right-hand side is positive, this represents a circle. So this is a circle. Yes, it represents a circle. I'm going to say because the right-hand side is positive, RHS for right-hand side, and its center is HK. Remember, you take the opposite sign from what's there. So if that's a +2, H is a -2. If that's a -3, K is a +3. R squared is 36, that's the right-hand side. And to get R by itself, you take the square root of both sides, and you get R equals 6. Okay, so that is our circle in standard form, and there's our HK and then our radius. So if I wanted to do this, I'd go out to -2, 3, plot that point, and I'm not going to do this one. I'm not going to try to be perfect with this one. I'm just going to go up 6 to 9 and down 6 to -3. Probably do a better job without the tick marks, honestly. And then we're going to go to the right 6 to 4 and to the left 6 to -8. Yeah, except for that bottom point, that's definitely not -3. We do that. Okay, and then just draw a curve connecting those. Oh, it's such a bad circle. It's supposed to be a circle, guys. That's supposed to be a circle, and the radius is supposed to be 6. So that's the idea. You complete two squares, and then you simplify. And if the right-hand side is positive, it's a circle. Now let's think about what would happen if the right-hand side was negative or if the right-hand side was 0. If the right-hand side, let's say it's the same left-hand side. Let's say it's negative. Let's say it's -16. You have to ask yourself, is there any x value or y value or xy pair that I can plug into this side that will give me a -16 when I'm done? You might say, well, how am I supposed to know? Well, remember, if I take an x plus 2, whatever x is, I take some number, I add 2 to it, and then I square it. This number, once it's squared, has to be positive unless it's 0. It could be 0 if x equals negative 2. Then I'd have 0 squared is 0. But if it's anything else, a negative squared is positive. A positive squared is positive. So this is positive except for when it's 0. And similarly, this is a perfect square too. So we're going to have a 0 here if y equals 3. But if y equals anything other than 3, y minus 3, if that's positive, you square it, it's positive. If y minus 3 is negative, you square it. Negative times negative is a positive. So this is something that is positive or 0 plus something that is positive or 0. If I add those together, am I ever getting negative 16? Say no. So if the right-hand side is negative, the graph, some authors say the graph is non-existent. I'm going to say the graph does not exist. There are no xy points that will satisfy this equation and give you a negative 16. Now let's say the right-hand side is 0. You get 0. Well, that's positive except for when it's 0, and that's positive except for when it's 0. It's only 0 one time. It's 0 when this in parentheses is 0 and when this in parentheses is 0. So it's 0 when x plus 2 is 0, which means that x equals negative 2, and simultaneously y minus 3 is 0, which means y equals 3. So you put those two pieces together, and you get xy equals negative 2, 3. If xy equals negative 2, 3, I get 0 squared plus 0 squared is 0. That's the only x value, or the only xy pair that works. So if you have a 0 on the right-hand side, the graph is a single point. You might even think of it as a circle with a 0 radius. That's our circle. That's it. That's all we've got. And that single point has coordinates h and k. So h is negative 2, k is 3. That's what the graph would look like. It's that single point at negative 2, 3. That's if the right-hand side is 0. Okay, so that's how we graph circles. It's how we graph circles and how we write them in standard form, and how we find the center and radius given a circle in standard form, and how we write the standard form given a center and radius.